I designed a 3D printed 5-inch racing drone frame, but before I show you how it goes together, you're probably going to want to know if it can survive a crash and how it flies. So here's some flight footage. Okay, now you've seen how this thing flies, let me show you how the frame goes together. You have two identical arms, two identical top and bottom plates, camera mount, VTX antenna mount. The thing I was going for with this design is simple and durable, so that's why you only have two different components for a frame. Alright, I'm going to switch views. Here's the hardware. There's 8 35mm standoffs, M3 bolts, and you're going to want to use blue thread locker on these bolts. Just put a drop right on the threads there and attach it. I'm going to skip that step for now to speed things up. I don't have anything against carbon fiber frames. I've been flying one for 3 years, but I've been wanting to build a fleet of drones, and I broke an arm on a carbon fiber frame and I ordered a replacement part and it was taking forever. My wife said, why don't you just 3D print an arm? And that kind of led to this, just 3D printing a whole frame. And so that's what I'm doing now. And it's way cheaper for me, and if it flies just as well and it can take a crash, that's just good enough for me. So, alright, when you're putting the arms together, this just slides over. It's going to be like a snug fit, which is what you want. So that's snug. Same thing on this side. And then you're going to notice that there's a gap right here. That gap gets filled up by the TPU, and this is slightly longer than that gap is, so that it compresses and then there's no give in this frame. Just going to finish the rest of the standoffs. Okay, so at this point you're going to want the camera mount like this, and this is a camera mount for, I've got the Foxeer Micro. I think it's like a 20mm gap between the camera mount. So you can see the camera goes right in between there. And then this is for the VTX mount, and which way does it go? Okay, so it goes this way. And then the top plate goes on, so you can see there's like a gap in there for the standoff, and then there's the hole for the bolt. So that gap right there takes some of the side loading on the column standoffs. That's one of the ways to make a plastic frame a little bit stronger, have the material work for you. Alright, and that's it. I'm going to finish off with these bolts. Okay, I just finished tightening all these bolts off camera, and now you can get an idea of what it looks like. This would be the front, and you can tell it's really strong. Yeah, so it's not going to be the lightest thing, especially compared to a carbon fiber frame, but just giving you a look, it's 145 grams, and then loaded up with the components minus the battery. It's about 342 grams. And again, I'm not going for the lightest thing ever, especially with how this handles on a 6S battery. For me, it's plenty fast, so I'm not trying to go lightweight. I'm just trying to get some durability out of the plastic material. Next, I'm going to transplant everything from this drone to this one, just so you can see it built from ground up. Okay, I've got everything laid out and ready to go. I forgot to mention that the frame is a stretch X configuration, just so you can have props in view. That's just my personal preference. Got the ESCs already soldered up to the motors. It's a Cyclone FPV ESC. I got a FlySky receiver. I'm not doing crossfire on this, but the thing about mounting the receiver or the antennas on a plastic drone is you can actually mount them on the frame component, because plastic doesn't block RF signal like carbon fiber does. So crossfire would mount like this, and then FrSky or FlySky I'd mount like this. So that's like a nice little perk to a 3D printed frame. And then my flight controller is a White Noise Synergy flight controller. Obviously you don't have to use these same things, you can use whatever you want. To get started, you have the option of 20 by 20 or 30 by 30 mounting holes. And I've got these little recesses in the plastic so that you can drop a little nut inside and it'll stop it from spinning. I'm just going to load my bolt in, speed things along. Okay, and I'm going to start with my battery strap because that's going to be pretty hard to fit in once you have your ESC in. Okay, now I'm going to put my spacers. And yeah, so being that the frame is the same both top and bottom, I think you can mount a battery up top. I haven't done that yet, so I'm not sure if it's exactly possible. But if you're mounting your battery on the bottom like I am, you're going to want to feed the XT60 through this hole right here. That'll also protect the wires from getting up into the props. Nope. Also keep in mind wherever you put your camera mount, that's front and this is back. I'm going to put my wires through between the two standoffs. And then you can see the nice thing about this frame is the plastic actually comes up and protects like your solder joints from outside debris. Okay, I've got all the motor bolts in except for one. I just want to point out these are long motor screws. That's because the plastic is about 9 millimeters thick in this area. Once again, the limitations of plastic mean you have to make it thicker to get the strength back. Also use Loctite, and if you want you can throw a washer on there too. Next is the FC. And then the I've got this bolted into the VTX antenna mount. Slide that down so the capacitor can sit right here in that little cutout there, and then everything fits nice and snug. I'm going to put some nuts on, hold the FC down. Okay. Next, I'm going to do the camera next. Okay. Now I can do the receiver. Okay, so when I tape the motor wires, I'm going to pull this down and tape right here. Reason for that is if you get a prop strike and your propeller's bent down, it will hit the frame first before it cuts your wires right there. Okay, and like I said earlier, I'm going to put the receiver antenna on the bottom of the frame. And we'll put a second piece of tape right here. And the last piece of tape right here. There you have it. Now, like I said earlier, those little recesses need to fit over top of these standoffs. Just make sure, go all the way around, and that has fit snug. Now you can put your bolts through the top, tighten everything down. Okay, I finished the bolts on the top of the frame here, added the VTX antenna, and at this point you can admire your build because it's the last time it's going to look this clean. Side view. Alright, let's go fly. Well, that's it for the build video. It's the first video I've made where I talk directly into the camera, so hopefully it turns out okay. If you do like the frame and you want to purchase it, you can buy it from Etsy. There's going to be a link in the description. Please give me your feedback because I'm going to be designing more 3D printed frames in the future and I'd love to hear what you think. I will be calling this the rainbow frame, but that won't be obvious until I show you this. At this point, you still might be feeling uncertain about flying a plastic frame. I'll be honest, out of all the times I have crashed the drone testing the frame, I did break the arms twice. But for me, that's the best part about this frame. I can just print replacement arms. For that reason, I will be putting the arms and the TPU mounts on Thingiverse for free download. I notice I fly with a lot more confidence when I'm not always worried about breaking something. My name is Sajjad, and thanks for watching.